Alright, today we're going to be talking about our proportions and similarity. So let's get started. Oh, just kidding. Hello. There it goes. Alright, so for proportions and similarity, so it's important to know a proportion is an equation written as two fractions with equal ratios. So your ratios are the two fractions. So you're going to cross multiply to solve. In this equation, if AD equals BC, then it is a proportion, but if AD does not, then it's not a proportion. So we're just determining, is it proportion, if it is or not, and then now we're going to solve it. So pretty easy. We're just going to go 6 times x, 9 times 20, solve for x, and you get x equals 30. So we're assuming these are a proportion, and we solved for it. Alright, this one, be careful, because if you notice, you have x plus 3 in the numerator. So when we solve it, we're going to go 4 times 2, which is 8. But when you're going this way, make sure it's 5 times the whole numerator. Very important. And then distribute, and you get 5x plus 15 equals 8. Subtract 15, divide by 5. You'll get x equals negative 7/5. So not too bad, as you've done cross multiplying before and you've done proportions before. It's just may have been a while. But go ahead, I want you to solve this one. Alright, and then now, here's some important information. Is to check for excluded and extraneous solutions. So excluded values and extraneous solution. If it's excluded, the values make the denominator equal to 0. And remember, you can't have 0 in the denominator. You can check for these by setting the denominator equal to 0 to see if it happens. Extraneous solutions are false answers to an equation. So again, plug it back into the original equation, and if it doesn't make sense for the situation, then it is extraneous information. It's a false answer. So let's start with similar. Two polygons are similar if and only if their corresponding angles are congruent and their sides are proportional. Now the symbol looks like the top of the congruent, but it's similar. So it looks like a little wavy line. So now let's go ahead and let's look at our example down here. So the angle marks tell you angle A is congruent to angle D, and angle B is congruent to E, and angle angle C is congruent to F. Therefore, corresponding angles are congruent. So far so good. So now we need to know, are the corresponding sides also are proportional? If they are, we have similar triangles. So we're going to set up corresponding sides, and we have 10 over 20, which is what I put here, and if you simplify that, you get 1/2. So now let's look at other corresponding sides. So we said BC and EF, 6 over 12, which is 1/2. So far so good, but all sides need to be proportional. So let's look. So CA over FD, we said 7 over 14 is 1/2. So since all three side lengths are proportional, they're all the same, they all simplify to the same. Therefore, the triangles are similar. And your similarity statement is triangle ABC is similar to triangle DEF. Alright, so now let's look at these two triangles. So it says triangle, so this is just like your congruency statement, but this is called a similarity statement. That's what that guy is. Okay, so now that we have our similarity statement, and we know because it has a similar sign, your triangle ABC is similar to triangle DEF. So remember, order matters. Order matters. So I know A and D are congruent. B and E angles are congruent, and then C and F are congruent. So each set of corresponding angles are congruent, so we are good here. Now we need to figure out, is this proportional? So what we need to do is look at your corresponding sides, AB, and then DE corresponds with that. So we said 8/4, which equals 2. You can put 2/1, but it's 2. Simplifies to 2. Then we can look at BC and EF, and that is 12/6, which also equals 2/1. So far so good, but we need all three. So let's look at the last. We have AC and DF, and that would be 10/5, and that's also 2/1. So that all three sides are proportional, then therefore these are similar triangles. Alright, so here we need to justify if the figures are similar. So let's go ahead and let's get started here. Now you have some square roots in here, that's okay. Let's figure out, so I know in here, let's see, do we have to do some? Yes, okay. Alright, so I know angle C and angle F are going to correspond with each other. I know that A and D are also going to go together. So then that means this angle and this angle have to go together, which would be 60 degrees. So all of our angles are congruent. So if your angles are congruent, sides proportional. That's what we're looking for. So now we need to figure out, oh, what happened here? It's like a little dance party with my letters. Okay. So now we need to figure out if it's proportional. So angles congruent, sides proportional. So let's look. So we're going to take our corresponding sides, AB to DE, because remember we went from 30 to 60, so 30 to 60. That's 12/9, which equals 4/3. Okay, so everything has to be 4/3. So now let's look at BC and EF, and that you get 6/4.5. Well, if you go ahead and simplify that and divide it out, so if you just basically, we made that by 2, that's where we got those from. Well, then this, to get rid of that decimal, this will simplify to 4/3. So far so good. Now we just need to figure out, is this last one also going to be proportional? So here you have AC and DF. So remember, we're going to put this over this to see if we got it. So 6√3 over 4.5√3. These actually cancel out and give you 1. And then you're left with 6/4.5. So we just multiplied that by 2. And we got 12/9, which equals 4/3. So now let's go ahead and let's write our congruency, or similarity statement, similarity statement at the bottom. So we said that angle A goes with angle D. We said that angle B and angle E go together. And then we said that angle C goes with angle F. So these are similar, and we know that because angles are congruent, sides proportional. So it has to pass both in order for it to be similar. Alright, what you're going to do is you're going to try this one, see how you do with that, and then we're going to go ahead and start talking about scale factor. Alright, scale factor, it's a ratio or a fraction where you compare the lengths of corresponding sides of similar figures. So we've actually talked about scale factor with transformations, but the scale factor is image over pre-image. Sometimes you'll see new over original, but remember, your new is your image and your original is your pre-image. So if you're not told or you can't tell which is the pre-image, assume the figure on your left or above the other. So in this case, it doesn't say which one's what. So we know that this is going to be the image, And this is the pre-image, because this is So we're going to go image over pre-image. It wasn't written, so I wrote it in for you. All right, so let's go ahead and let's look. So EH, to the pre-image here. So EH is 7, and then that goes with 14, and you get 1/2. So we know that if this is similar, all the sides should be increase or decrease by multiplied by 1/2. So in this case, it's going to shrink, or it's going to be a reduction by 1/2. So now let's find our missing side. So if I've got here and here, well, I know for my pre-image it's 13, and then I know for my image it's x, and then just cross multiply, and you get 2x equals 13, and you could do 13/2 or 6.5. All right, now for this one, again, this is your left is your pre-image. So this is your pre, this is your image. So you're going to start and go that way, start and go that way, if it doesn't say. All right, so let's look at the easy ones as given. So I've got my new over original to find the scale factor. So this is going to be an enlargement of 3. And then now to find x. So you're going to look for which side has x on it, and then find the corresponding side that goes with it. So we have x plus 5 over 4. And then you're going to go ahead and you're going to cross multiply. But remember, this is in parentheses, which doesn't matter in this situation. But you'll get x plus 5, and then cross multiply here, you'll get 12. So x equals 7. All right, you're going to do this one, you're going to do this one, and then just remember, if it doesn't say, you know this is going to be your pre, this is going to be your image. Pre, image, if it doesn't say. All right, now this one is actually, it's kind of easy, just is very wordy, but if you have triangle ABC is similar to triangle XYZ with the scale factor of 2/3, if the lengths of the sides are 6, 8, 10, what are the lengths of the sides of the new triangle or the image? So since ABC is listed first, this is the pre-image. All right, so now we know. So all you're doing is just taking your sides times the scale factor. So sides times your scale factor, I'll take that out just so that way you can see. So side times your scale factor will give you the image. Pre-image side times the scale factor gives you your image. So super easy, we just took 6 times the scale factor, 8 times the scale factor, 10 times the scale factor. We got our new lengths. All right, so that wasn't too bad. It's just remembering that it's proportional. So the biggest thing for similar is the angles have to be congruent and the sides have to be proportional.